Okay, hi everyone. Welcome to this section 1.6 self-check exercises. Let's go over number one. So number one is asking find the average rate of change of the function f of x with respect to x on the interval. And we got this function here, f of x equals 3 times the square root of x minus 3 on the interval from 9 to 36. Okay, so remember that average rate of change, right? We've talked about this in I think 1.3 briefly, but it's like f of x2 minus f of x1 over x2 minus x1. That's really just like the slope, y2 minus y1 over x2 minus x1. And we're going to use the same formula to find this. So to find the average rate of change on this interval 9 to 36, this is just f of 36 minus f of 9 all over 36 minus 9. So off the side here, we're going to figure out what f of 36 is and what f of 39 is. So f of 36, we're plugging it into this f of x right here. So off to the side here, this becomes 3 times the square root of 36 minus 3. So that would be 3 square root of 36 is 6 minus 3. So that's 18 minus 3, which is just 5. So next one is f of 9. So same thing, we're going to plug in 9 into the function. So 3 times the square root of 9 minus 3, which is just 3 times 3 minus 3, which is just, 9 minus 3, which is just 6. Okay, great. So put these guys back in here respectively, right? Putting them right there. And what we get is 5. We get, yeah, it should be 15. Quick typo right there. 15 minus 6 all over 36 minus 9, which is just 27. Okay, so 15 minus 6 is 9. So it's 9 over 27. And then this reduces down to you divide the top and the bottom by 9. So that would just be 1/3. So that's the average rate of change from 9 to 36 of this function. Okay, so say to number one. And number two, find the instantaneous rate of change of the function. Okay, so remember we learned two different ways to do it, one using average rate of change and one using the actual definition of a derivative. So let's go ahead and try both ways and you can choose which one you prefer. So let's use a one-way definition of a derivative. Derivative. Okay. So, so I don't say definition of derivative, maybe instantaneous rate of change. Let's go with that. Instantaneous rate of change. Okay, let's go with that. So remember that is limit as h goes to 0 of f of x plus h minus f of x all over h, right? So here, we're going to use this definition here. And so what we're going to do is now substitute in our function. So remember that instantaneous rate of change is just the slope of that tangent line. So this would be limit as h goes to 0, f of, this is our x, so 1 plus h minus f of 1 all over h. Remember that this x is being substituted with that guy. Okay, so let's just keep going. And so this becomes the limit as h goes to 0. And this whole 1 plus h is our input, so we're going to plug it in wherever there is an x. So this becomes, this first part here is 5 times 1 plus h minus 2 minus the second part here, and you're just plugging 1 into the function. So f times 1 minus 2, still all over h. Okay, so if you distribute in this guy there, that guy there, distributing the negative here, right? You end up getting limit as h goes to 0, 5 plus 5h minus 2 minus 5 plus 2 all over h. All right, so then you start to see some things cancel out. So this 5 cancels out with that negative 5, negative 2 cancels out with 2. And so what you're left with, right, limit as h goes to 0 is 5h over h. Well, that works out really well too because this gets canceled out. So the answer is just 5. So that's the instantaneous rate of change. That's the slope of the tangent line. Okay, so that's one way to do it with like the the tangent sort of limit definition. So let's go ahead and try a different way. Maybe this is a little easier for you since maybe it's a little more familiar. But we can also just use our average rate of changes. So here's that second way where we just find the average rate of change. So second way, average rate of change around x equals 1. Okay, so what I'm going to do is find the average rate of change from 0 to 1. Oops, let me write that again. From 0 to 1 and 1 to 2 and take the average of that. All right, so let's go ahead and check out what we mean. So I'm going to find the average rate of change. So average rate of change on 0 to 1. Okay, so that becomes f of 1 minus f of 0 all over 1 minus 0, right? We're still using this guy up here, 5x minus 2. So this becomes 5 times 1 minus 2 minus 5 times 0 minus 2. Okay, and this is all over 1. 1 minus 0 is 1. And so this ends up being, 5 minus 2 minus negative 2 all over 1. So this ends up being 3 negative times a negative is positive. 3 plus 2 over 1, which is just 5 over 1, which is just 5. Okay, so that's the first average rate of change. Now we want to find the second one. Remember, we're just getting them around x equals 1. So one below it and one above it. All right, so let's check that out. So average rate of change on 1 to 2. So this becomes f of 2 minus f of 1 all over 2 minus 1. So f of 2, recall that the function, right? F of x equals 5x minus 2, right? So we're plugging in 2. This is 5 times 2 minus 2 minus 5 times 1 minus 2 all over 2 minus 1. Okay, so this ends up being 10 minus 2 for this first one minus 5 minus 2. So all over 2 minus 1. This ends up being 8 minus, this ends up being 3. And then the negative makes it a negative 3. So minus 3 all over 1, which is just 5 over 1, which is just 5. Okay, great. So we have 5 and 5. And now the last step to do for that is take the average of them. All right, so finding the average would be you just take your 5 and you take your 5. You average that out, so you divide it by 2 since there's 2 of them. So that's 10 over 2, which is just 5. So that's the instantaneous rate of change of f of x equals 5x minus 2 at x equals 1. All right, and notice it's the same exact thing that we got up here, right? Whichever way you want to do them is up to you. This one's the more official way to find instantaneous rate of change. This one's more of an approximation, but if you do an approximation, you should get close enough. Okay, so that's it for 1.6. I'll see you next time. Thank you.